So guys, I'm just going to take you through the functions that you're supposed to plot on the same set of x's. Of course, I'm going to use GeoGebra here. We're going to start with y equals to x. I hope you can see that. The important thing to see here is that actually it passes at the origin and it is evenly spaced. If you were to check this side here and this side here, this function is actually you will see when we discuss the hyperbola in grade 11 that this function is very, very perfect, perfectly. So you can say plotted. There is nothing really that has been done to the gradient. The gradient is 1 and so forth. Now, let us look at another function that is y equal to 2x. You can see now what happens is the function and now, because of the gradient being greater than 1, it starts sort of being closer to the y-axis, so to say. Maybe I should try and put a different color on this one so that we can kind of differentiate on what is happening here. So that's the color, and I can put even another function y equals to 3x, and you can see also where this line seems to be going. So you see the effect that the gradient actually has on the function. That is the most important thing that I need you to see from this, what the gradient does. So let's put the last one, y equals to 3x, and let's see where that goes. Here it is, y equals to 3x, or I had put that actually. So let me put 5x. Yes, let me put 5x. So you can see even with this one here, as I said, you can see the graph gets closer and closer actually to the y-axis. All right, so that is the critical part that you guys have got to understand from this. Then I said you're gonna use the one where there is half x. So let's see what is going to happen here. Y equals to, in other words, x over 2. And you can see now, I'm going to start this one with a red color, and so that we can see what is actually going on here. So you can see now, once I go to y equals to half x, it is actually bending towards the x-axis. You see, that's your red one, the one in red. And I can even go ahead and say, well, what about x over 3? You can see it is also bending more to the x-axis. I will come to the real interpretation of this, how you actually should interpret it. And let's see again, as I decrease the gradient, in other words, you can see where I'm going. I am gradually getting closer and closer to the x-axis. Let's take the fifth one, say y equals to now x over 5. And you can see here it is again closer we are getting to our x-axis. Maybe let's take the last one, y equals to x over let's say 8. There we are. Sorry, I did not type that correctly. Let me retype that, y equals to x over 8, and there it is. I will stop there and now talk about the meaning of this. So this graph here is our original graph, okay? I just want to take a suitable color. I think red will do. This graph here is our original function, y equals to x. This one here, y equals to x. And these three graphs show us what happens when the gradient, rather, not y, when the gradient is greater than 1. And these ones here show us what happens when the gradient is less than 1. Now, what is very, very important to note here is that I'm saying the gradient, okay? So I should not, I'm sorry about this, I should not be saying y, okay? The gradient is m, so I should be saying m greater than 1. here I should be saying m less than 1, right? But what is important is that the gradient is greater than 0, although it is less than 1. So here the gradient is between 0 and 1. You will get graphs that are actually closer to, the line is actually closer to the x-axis. But the real interpretation is that actually the slope, that is the important part. Remember, gradient is a slope. So the slope is actually less steeper, okay? The slope of the line is less steeper, and it is because it is what? It is just between 0 and 1, okay? If you think of a line which the slope is 0, it is actually the line y equals to a constant. Remember that it is the line which is parallel to what? To the x-axis. We spoke about that. So the x-axis itself is actually the line y equals to 0. That is another simple way to think of the x-axis. So we can see the slope is less steeper when the gradient is between 0 and 1. But once the gradient is bigger than 1, we can expect a slope that is way steeper, to a point that you can't really walk on this. Here, this is where you need ropes to climb walls, things like that. So if you can think of it in that way. So that is what I wanted you guys to get about the gradient, how it is when how the graph is, how steep the line is, how close it is to the x-axis or how close it is to the y-axis, depends really on the size of the gradient, okay? That is the important thing that I want you guys to get out of this. In the next video, we're going to now look at the negative numbers now, the negative gradient, and how things work, okay? Cheers.